to remind you English. Let's speak English, not chemistry. Submarine. What does the word submarine mean? Sub meaning down inside. Marine meaning water. Subscript meaning down and number. So the numbers that are written below, we call it subscript. The numbers that are written before the molecule or before the element, like 2 here, like the 2 here, like the 2 here, are called coefficient. From this, I can tell you that I have 4 atoms of aluminum, and I can tell you I have 6 atoms of oxygen. What do I mean? I mean that this 2 is related to whatever written after it. Okay, how about this 3? This 3 is related only to oxygen. How about this 2? This 2 is related only to aluminum. That is important, very important. Very important. Tell me if you don't get it.
I don't understand.
Okay. What I'm showing you right now is I'm putting numbers either below atom or beside atom. What do I mean again? If you're saying 2N2, this 2, which is written below, is called subscript. This 2 is called coefficient. In order for you to know the number of atoms present, you need both. So nitrogen, I have 4 of the nitrogen atom present. Are we good? Maria?
Yes.
Okay, let's see this. So 3Al2, meaning how many atoms of aluminum?
6.
Okay, 3 times 2. Okay, if the molecule is like this, so you said 6 aluminum because the 3 is referring to all of this. So 3 times 2 equals 6 if you're talking about aluminum. Okay, how about oxygen? How many atoms of oxygen are there?
There's 3.
3. But how about this 3? This 3 refers to what? Is it referring to aluminum alone or referring to all?
All.
So the O3 is repeated how many times?
3 times.
So how many atoms of oxygen now?
9.
Thank you. Meaning that this 3, which is the coefficient, is telling you how many times all of this is repeated. Can I give another example?
Yes.
Okay, let's go for this. How many atoms do I have of sodium? Can someone help me? How many atoms of sodium do I have? Anyone?
4.
From where you brought the 4?
Oh no. I don't know.
This 2 refers to whom? First, how many elements do you see? I see sodium, and I see sulfur, and I see oxygen, right?
Yes.
This 2 refers to sodium, so I have 2 atoms of sodium. How many atoms of sulfur do you think I have?
But sulfur is connected to oxygen.
How many atoms of sulfur do you see? It's not a difficult question. Anyone? Lilo, how many atoms of sulfur do you see in that molecule? Lilo, where are you? Batul, Ambara, anyone? Lilo, how many?
Where?
Sulfur, how many atoms of sulfur?
3.
From where you got 3?
I can't really see any.
Is anything written below sulfur, guys?
No.
Meaning 1. We don't write the 1. So if there is nothing written, meaning sulfur 1. If no subscript written below sulfur, therefore sulfur is 1. How many atoms of oxygen now? You tell me 4. Because this 4 refers only to oxygen. Nothing is written here meaning 1, meaning sulfur is 1. Subscript for sodium is written after sodium and below it. Can I give another example?
Yes.
Okay, let's see one from the periodic here. Let's take V. Let's say you are talking about this. How many atoms of magnesium do you see?
1.
Correct. How many atoms of chlorine do you see?
2.
2.
Thank you. That's it. That's as easy as it is. Yes, correct. Let's have another example. How many atoms first do I have? I can see I have aluminum, I see sulfur, I see oxygen. How many atoms of aluminum do I have?
2.
Thank you. 2. How many atoms of sulfur do I have?
4.
From where you brought the 4, please?
1.
No, I can't see.
Are you opening Mary's screen?
Yes.
Not my screen.
Yes.
And you can't see?
معلش ممكن يكون something with my Wi-Fi.
Okay. Khalid is saying 3. Correct, Khalid. Thank you. Why Khalid said 3? I'll tell you. Because Khalid said this 3 is covering the whole bracket. And the subscript for sulfur is 1. Nothing is written here, so it is 1. So 1 times 3, which is in the whole bracket, equals 3. Can someone tell me how many oxygen do I have? What's up, guys? How many atoms of oxygen do I have?
12.
12. Thank you, 12. From where you brought the 12? 4 times 3. equals 12. Thank you, guys. Very nice. So is it easy or difficult?
Easy.
Okay, let me tell you why I'm saying this lesson is important. When you say Al2O3, that is called a molecule made of two atoms. Aluminum bonded with oxygen, right? How bond?
Yeah.
How they bond together? This is the whole idea about our lesson today. So to tell you how this happened, I have to remind you of a rule we took before called the octet rule. What's the octet rule? Oct meaning 8, if you can remember. What's the octet rule? Octet rule is telling me that every single element tends to lose or gain or share number of electrons to be like the nearest noble gas having 8 electrons in his outermost energy level, so he will be stable. Do we agree on this? Do you remember this part?
Yes.
Okay, from this part we are going to learn something called chemical bonds. Please, on a piece of paper, take notice, this is important. Chemical bonds. What are chemical bonds? There are two types. First type is called ionic bond. Second type is called covalent bond. So how many types of bonds? Two. Ionic and covalent. Ionic bond is the bond that is going to be formed between when metal reacts with non-metal. The bond that is going to form is called ionic bond. Metal and non-metal reacting together. Covalent bond, when non-metal react with non-metal. The result is going to be called covalent bond. So we are going to study about types of bonds. You will learn about something called ionic bond. This bond formed between metal reacting with non-metal. Very strong bond, very strong bond, very strong. Covalent bond, we are going to study it as well. When non-metal will react with non-metal. This is a summary, guys. I'm giving the summary first, then we will go to the details of every single one of them. So please write this and tell me if I can erase the board. Okay, you can take a screenshot. I don't know if the screenshot is going to be clear to see. I have no idea. You know better than me. You can write it. You can take a screenshot. It's up to you. Can I erase the board, guys?
Yes.
Anyone not yet? Okay. So to understand the chemical bonds, I have to go to the difference between metal and non-metal. What are metals? What are non-metals? That's number one. I need to go through it. So let me put metal versus non-metal. Metals are any element that have one or two or three electrons in the outermost energy level. Again, so you can write with me or you can take a picture or whatever. Any element that has one or two or three electrons in his outermost energy levels, meaning the valence electron, that is
Mr. Rahab, can I wait for you to write everything and then take a screenshot?
Yes, dear, you can do whatever you like. Yes, of course.
Okay,
You're welcome, my dear. So any element contain one or two or three electrons in the outermost energy level, we call it valence electrons. That is a metal. Let's have an example. Example. Sodium 11, meaning 2, 8, 1. Sodium has one electron in the outermost energy level, therefore sodium is a metal. Another example, aluminum 13, meaning 2, 8, 3. Valence electron 3, meaning aluminum is a metal. Of course, the normal thing about metal is lustrous, metal is shiny, metal crystal or solid, metal conduct electric current, all of these properties, I know you know it. Metal ductile, important always in any quiz. What does the word ductile mean? Meaning can be squeezed into wire. Metals are malleable. What does the word malleable mean? Can be hammered into sheets like aluminum. All of these properties, I know you know it about metal. This is new. So number one, metal, any element contain one or two or three electrons as a valency. That's called a metal. I gave you example here for sodium, 281, meaning metal. Aluminum, 283, meaning metal. Let me erase sodium and take aluminum. Sorry for this. Let's continue with aluminum as our example. We said aluminum, 13, meaning 283. So aluminum will lose 3 electrons to be stable like the nearest noble gas. Are you following, guys? Do you know why aluminum lost 3?
Mister, I don't understand.
Aluminum, dear, 283. Do you understand this?
Yes.
Okay, and aluminum from the periodic table. Look at my periodic table. Here is aluminum, right? Aluminum would like to be stable, right? Like the nearest noble gas. So aluminum will lose or gain. Could you tell me? Lose or gain electrons, of course.
Lose
How many?
from the valence electrons?
Yes. Or from
It
you
would lose
can
3.
yes, you can predict it from the valence electron, which is the outermost, or you can predict it as we mentioned before. All of these elements will lose 1. All of these elements will lose 2. We jump this area. All of these elements will lose 3. You remember this?
Yes.
After that, I told you after losing 3, stop. 0, no lose, no gain. They are noble gases. -1, they gain 1. -2, they gain 2. -3, they gain 3. Plus or -4, which is the group of carbon, according to the chemical reaction. Let's return back to the board, whiteboard here. So in the whiteboard, you said aluminum, when he loses 3, he will be having 8, like the nearest noble gas. Aluminum now is stable, right? Guys, am I right? Any problem? If you don't understand, please stop me.
Mr. Starting, which group do the electrons lose
Group
energy?
1, no, it's not energy, it's electrons.
Electrons?
They lose electrons in group 1, in group 2, in group 3. How many they lose in group 1? All of them lose 1 electron. Group 2, all of them lose 2 electrons.
And group 3 loses 3?
3 electrons. How about the middle part, this part? They also lose. They are metal. Metal always lose. But they lose more than 1 valency, more than 1 oxidation number they have here. You will learn it later with me. So again, something very important. Metal always lose electrons to be stable like the nearest noble gas. I will erase this part and return to it later. So metal always lose. So let's return back to aluminum. Aluminum 283, number of positive protons 13, number of negative electrons 13. Am I correct, guys?
Yes.
The new aluminum, the stable aluminum, is called aluminum, and we're going to see the stable one. How many positive charges does he have? Please, can someone help me? The stable, the new aluminum, how many? What's wrong?
10?
10. He lost protons, Maria?
No, he lost electrons.
So how many protons?
13?
Nothing changed, 13. How many electrons, Maria?
10?
Thank you. Could you tell me which is bigger, the positive or the negative?
The protons?
By how many?
3.
So positive is bigger than negative by 3, that's why you will write it plus 3. You understand now?
Yes.
Okay, and we are going to call it, so the new aluminum, the stable aluminum, which is aluminum 3+, having the same electronic configuration like the nearest noble gas, but is not noble gas, remember. That is called cation ion. Cation ion. That is ion, not atom. What do you mean? Hold on, I'll tell you after a second. But first remember, losing cation. When an element loses electrons, cation. And I'm making a sign over the cross here and the cross here, so you relate them together so you don't forget it. Let me give you another example here quickly. Oxygen, 8, 2, 6. For oxygen to be stable, he will gain 2 electrons. So the new oxygen, the positive charge 8, negative electron after gaining 10, meaning that the new oxygen, the negative is bigger than the positive by 2, so you will write -2. You will call it anion ion. So I learned 2 words now. I learned the word cation ion. I learned the word anion ion. I learned the word ion. Let's say it again. Ion is any element lost or gained electron. If he lost electrons, I will call him cation. I will give him the charge of positive. If he gained electrons, the element will be called anion. Is not an element anymore. It's called anion ion. It's carrying a negative charge. Let's have this thing quickly. So again, when we are speaking about the metal, remember we are differentiating now between metal, non-metal. Metal always lose electrons. Metal always positive in charge. Metals are called cation ion. I made even charge like this so you can remember. Let's go to non-metal quickly. So therefore, non-metals, any element that carries 5, 6, 7 electrons as valency in the outermost energy level. Electrons in outermost energy level. Example, chlorine 17, 287, carry 7 in the outermost energy level. 7. So it's non-metal. Oxygen 8, meaning 2, 6, carry 6 in the outermost energy level. Valency. Therefore, oxygen is non-metal. Remember, we just took before non-metals just now. Non-metals are always gaining electrons. Non-metals are negative in charge. Non-metals are called anion ion.
So ions are negative
Yes, dear.
and cation ion are positive.
are positive. Yes, dear. What does
And
the word
ions
positive?
are
Hold on. What does the word positive mean? Meaning he lost electrons. What does the word negative mean? Meaning he gained electrons.
gained.
And if I ask you about this word alone, this word, what's an ion?
Neutral?
No. What's an ion? No.
Oh,
Ion
no.
could be cation or could be anion.
Anion.
Could
Yes.
be this or this. So an ion is either positive or negative. I don't know. I will know when you continue the word. Are you talking about cation? If cation, therefore it is positive. Therefore it is metal. If you are talking about anion, therefore it is negative, therefore it is gaining, therefore it is non-metal. Very important what we're talking today, very important. Have you noticed that I have missing two numbers? Here is 1, 2, 3, where is 4? 5, 6, 7, where is 8? Simple. 8, any element carrying 8 electrons in the outermost energy level, he is called noble. He is a noble gas. So what about 4? 4 are called either semi-metal or semiconductor or metalloids. Remember, they differentiate between the metal and non-metal. How is that? They have the appearance of metal, but the properties of non-metal start to appear. Guys, tell me you are good. We took all of that before. Any question, please, now?
So 8 are noble gases
Always noble gases.
and 4 semi-metals.
Or semiconductor, or metalloids.
Metalloids, then what is 6?
6 is here.
Yes, non-metals?
Yes. 1, 2, 3 is metal. 4 non-metal. 4 semi-metal. 5, 6, or 7 non-metal. 8 are noble gases.
Okay.
Guys, very important lesson. Please tell me now. Tomorrow I will start with the chemical bonds, meaning the part of the ionic, the part of the covalent. But for now, please, if you take a picture or whatever you need, write it. I'll give you a chance to write it. But this is important. Here I will write semi-metal, or another name, metalloids, or another name, semiconductor. This is very important, guys. Very important. Because of this, tomorrow I can show you the bonding very easily. It won't take 10 minutes. The bonding, which is the ionic and the covalent. But today's lesson, very, very, very important. If there is a part you are missing about today's lesson, please, now, you tell me now. Any questions before I continue?
No.
Vilo, Ambarak, Batul,
No.
Ranim, anyone, guys?
No.
Okay. Now, have you finished this, or do you want me to give you a minute to write it? Sorry? Okay, guys, I'll give you a minute to write this. Please write it quickly. Can I erase the board, guys, now? Anyone?
Yes.
Yes.
Okay. Let's now close Mary's screen and return back to my screen. I'll close Mary from here. And let's open our today's lesson in Google Classroom, please, today. you will find that I have shared with you putting atoms together. It is not finished yet. We are just taking an idea about it, but it's not finished yet. Here, which is 7.1. I'm just taking a look at 7.1 with you. Putting atoms together. Most things are not made of individual atoms. Atoms can chemically join with other atoms to form something called a molecule. So what is a molecule? Full stop. Very important. What is a very important? What is a molecule?
Two or more atoms
Thank you.
of the element joined.
Thank you here. On the, I will need to change only one single word you said. Let's read it on the right-hand side. Molecule are two or more atoms of same or different element that are chemically joined. I need the word chemically. Why? Because the new, if you remember from before, we took the difference between physical and chemical. When they are bonded, the new thing is in new material. Let's say carbon plus oxygen give you carbon dioxide. Carbon dioxide is not anymore carbon. It's not anymore oxygen. It's a new material called carbon dioxide, which is a result of chemical joining, chemical combination between you and me, which is a chemical bond. This is what we're going to explain tomorrow. So as Maria mentioned, molecules, any two or more atoms bonded together chemically. That's a molecule. Now, chemical formula for a single nitrogen molecule, two atoms bonded together, it is N2. What's the chemical formula? That's the formation of the new material that we're talking about. Notation used to indicate the type and the number of atoms. Meaning, if you can remember, we spoke a few minutes ago about the word subscript, which is written below the elements, after the elements and below it, showing that I have two nitrogen here. And we spoke between you and me about another word called coefficient, which is written before the element. Now, we have 7 molecular elements in the periodic table. 7 diatomic molecules. How many? 7. Can we see the 7 together? Here they are. Count with me 7, please. It is like inverted letter of L. Count starting from iodine. 1, 2, 3, 4, 5, 6, and hydrogen number 7. So I have 7 elements in the periodic table. They are always di. You never write hydrogen H. You never write oxygen O. You always write oxygen O2, hydrogen H2. How many elements like that in the periodic table? We have 7 elements like that. We call them the 7 di. Di meaning 2. The 7 diatomic elements. Diatomic molecules, to be accurate. The 7 di meaning 2, atomic molecules. Why do you call them molecules? Because they are molecules, more than one atom joined together. How many they are again? They are 7. Do I have to remember them? Yes, you must. Because in a chemical equation, you never write nitrogen as N. You always write it as N2. It's a molecular element. It is one of the 7 diatomic. Are we clear, guys? This is important. Then I will stop here. What's a molecular compound? Not now. All of this, not now. That's about tomorrow. So all we took today about 7.1 is the 2 pages here. Besides what I mentioned on the whiteboard, and you wrote it with me, because without what's mentioned on the whiteboard, you will be lost tomorrow. So please, all I'm asking about today, just read what we took today from your copybook. I don't care about the book. If you didn't open the book, I don't care. Don't open it. I don't care. Khalid, you wrote so many things. Sorry, I missed it. I was on the board, so I couldn't see what you were writing at that time. Guys, I will take the attendance. So please say anything so I can figure that you're here, not your name on the board. What we just wrote today, most of it is not in the book, but without it you can't understand anything about chemistry. Batul, are you here?
Yes.
Khalid. Khalid, are you here? So it's your name only, or are you here? Khalid absent. Raneem, are you here?
Yes.
Thank you, dear. Lilo?
Yes.
Reem? Maria?
Yes.
Ambara? Ambara, you brought a mic. Are you here or absent?
Yeah, I'm here, man.
Yeah, thank you. Now you're here, my dear. Okay. Maya, are you here? Maya is not here, guys. Ambara, tell Khalid is absent unless he replies now.
Mine is not here.
Maya is not here. Okay. So in today's lesson on Google Classroom, you will see two things together. 7.1, we took only 2 pages, 2 slides, I mean. Then you will find periodic table quiz. That's intended for 5 minutes, 9 marks. It's 12:02. Meaning you have 8 minutes. Now, please. Now, please.
After we do it.
Now, after you do it, you submit it to my email. And notice I'm wasting your time because that's more than the time required. What do I mean? Meaning I'm not going to accept any answers after 12:10.
Okay.
Now, go ahead, guys. Ambar, I received your assignment, yes? Maria, I received yours. Lilo, I received yours as well.
Mister, I sent you mine.
When was that? That was early
Before the
today.
lesson. Before the
Yes,
lesson.
Ranim, I received. I said I received yours, dear. You and Batul were the first.
I didn't see my name.
No, I mentioned it in the beginning of the lesson. I said I received it from Ranim and I received it from Batul. Ambarak, tell him he's absent for me because he's not attending the lesson. His name is attending, but he's not attending. So he's absent. Okay, he was what? Now he's not. He came, he shows himself, now he's not. Khalid, are you here? Could you write for us if you are here? Okay. His not even on the chat. Okay, what can I do? Nothing on my hand at this point. Don't waste your time, Mubarak. Finish what you have. That's your exit ticket. Remaining 6 minutes. Thank you, Mubarak, for update.
Mister,
Yes, dear.
for number 2, it says how many naturally occurring elements are there? Like, am I supposed to say how many elements are in the periodic table? Or just how many natural?
No. If you read the introduction of the periodic table, you will see that we have a question of natural and synthetic. The periodic table, we mentioned that something are natural, something are synthetic elements. Synthetic means made by a scientist in the lab. This question is asking about the natural occurring. How many in nature? How many found in nature? I know it's not in your book, but we have mentioned it. So don't worry about its mark, but worry about knowing it. We are learning together, Maria. It's not about mark. This one is not about mark. That's not a quiz. That's an exit ticket. Not about mark.
Yes, but there's 118 elements and there's 94 natural.
98, you mean? Because
98?
94 is not written.
Yes.
Okay.
Mr. Ahab, I finished. I'm gonna send it to you now.
Please do it now, yes. Thank you, dear.
I sent it. Can you check if you got it?
I'm checking it here. Not yet received. Wait. Receive it on second. Received, Lil. Thank you, sweetheart. I don't know if you understand that every lesson when I give you something like this, at the end of the day, like 8, 9 p.m., I post the model answer, right? You understand that?
Yes.
Thank you, dear. Thank you for attending my lesson. You have a great day, everyone. See you all tomorrow. Enjoy the rest of your day. Be healthy. Stay safe. After you finish, you send it. That's going to be late. So get something better than nothing.